Hi friends, welcome to Cat Engineers Academy YouTube channel. Myself, A Tirupati. Today we will discuss how to solve the problems in electrical circuits by using mesh analysis. Okay, then we will go for the problem. See here, they are given one problem, that is for the circuit shown in figure. For the circuit shown in figure, find the branch currents I1, I2, I3 using mesh analysis. Okay friends, so by using mesh analysis we have to solve the problem of this one. Okay, then how to solve the problem by using mesh analysis we have to see. Okay, so next already I explained how to what is a mesh analysis and application of mesh analysis. Okay friends, already I given one video. Just you refer that video in order to get the clear idea. Now today we will see how to solve the problem. Okay, now here they are given, this is the circuit. The circuit consisting of 5 ohms, 10 ohms, 6 ohms and 4 ohms elements. Next 15 volts and 10 volts are the sources. So finally we are having the circuit as like this. Here we need to find out what is I1 and I2, what is the I3. That I1, I2, I3 we have to determine by using the mesh analysis. Okay, now already I given the procedure. By using mesh analysis we are having 4 steps. So just to follow the 4 steps, finally we will get the answer. Mesh analysis is nothing but, first, what is the main aim of mesh analysis? We need to determine the loop currents. Okay friends, now let's start the problem. First step is, just here I am considering the step 1. So this is step 1. Step 1 is, first identify the number of meshes. So here you have to find out first total number of meshes. Total number of meshes. Total number of meshes. So here total number of meshes are just here. This is one mesh, this is another mesh. So finally we are having the two meshes. So here we are having the two meshes. Then step 2. So what is the step 2 is nothing but assign mesh currents. Assign mesh currents. Assign mesh currents. So those mesh currents here I consider that are the I1, small I1 and I2. So here first you have to assume the mesh current. So finally here I consider this is one mesh, this is another mesh. So in this mesh here I consider the current direction as like this clockwise. Next this current is I consider as small I1. Next from the second loop you have to consider one more current direction. Always you can consider current direction as you wish, no problem. Either it is clockwise, otherwise anti-clockwise direction. So here I consider the directions are I1 and I2. Then here two steps are over. So already I told that for total we are having the 4 steps. In that 2 steps are over. First step is first identify the total number of meshes. Next you have to give the mesh currents. Okay friends. Next you go for the step 3. Step 3. So what is the step 3 is? So step 3, write KVL equations. Write KVL equations to meshes. Write KVL equations to meshes. Nothing but how many meshes we are having. For each and every mesh we have to write one KVL equation. So first here I consider the first one. So first apply KVL to mesh 1. To mesh 1. So mesh 1 is nothing but this is the mesh 1. So for this mesh 1 we have to apply the KVL equation. So according to the KVL equation, algebraic sum of voltage in a closed loop is 0. So based on that we have to develop the equations. Okay, then how to develop the equation? Just listen. Here we are having in this loop 15 volts, 5 ohms, 10 ohms and 10 volts. So just listen here how we are writing the KVL equation. The KVL equation here consider the rise in potential is considered as a negative, drop in potential here I consider as a positive. Okay, so finally it is first we are having in this is 15 volts, it is negative to positive is nothing but it is rise in potential. So here I consider this rise in potential is minus 15, here I consider as a negative. Next here current is entering into the 5 ohms here starting. So finally I consider this one starting. Always the elements are here we are having positive. Here we are having negative. Okay, current direction is whatever the current is entering into the resistor is considered as a positive, leaving is negative. So it is a drop in potential is nothing but you are considered as a positive. So finally, what is the current flowing through the 5 ohms is I1. So small 5 into small I. Next we are having the 10 ohms. But in 10 ohms, two currents are flowing, I1 and I2. I1 is downwards, I2 is upward with respect to first loop. So that I1 is the positive. So finally, plus 10 I1 minus I2. I1 minus I2. Next we are having 10 volts plus 2 minus nothing but drop in potential. Drop in potential I would consider as a positive. So positive 10 equal to 0. So finally this is the KVL equation. Now simplify this KVL equation. Minus 15. So 10 I1 5 1 is withdrawn. We will get the 15 I1. Next minus 10 I2. Next plus 10 equal to 0. Now if I simplify this equation, here this 15 minus 15, 10 is nothing but minus 5. Here we will get the 15, here we will get the 10. So finally you take that 5 as a common. Finally we will get the answer is 3 I1 minus 2 I2 equal to 1. Now finally you consider this equation number as first equation. Okay friends, so first apply KVL to mesh 1 is over. Next I have to go for the apply KVL to mesh 2. Then go for the second loop. So in the second loop, what are the elements we are having? 6 ohms, 4 ohms. 6 ohms I2 current is flowing, 4 ohms I2 current is flowing. Next 10 volts, next 10 ohms. So 6 I2 plus 4 I2. Next minus 2 10 minus 10. Next 10 I2 minus I1 because both the currents are flowing in the 10 ohms. So with respect to second mesh, so finally got the I2 minus I1. So with respect to which loop is first, that current you have to consider the first one. Next elements are first 6 I2, next plus 4 I2. Next we are having 10 minus 2 plus 2, so that we have to consider as a minus 10. Next plus 10 I2 minus I1 equal to 0. So apply second loop. This is the second loop equation. Now you have to simplify this equation. So here we'll get the this is 10 I2, 6 I2 plus 4 I2, 10 I2. So finally we get the 20 I2. Next minus 10 I1. Next minus 10 equal to 0. Just take the 10 as a common. Finally we get the minus I1 plus 2 I2 next equal to 1. Now you have to consider this equation second. Now this is the step. So step 3 is we have to develop the KVL equations. Next you go for the step 4. Step 4, solve KVL equations. Solve KVL equations to obtain mesh currents. So for us in order to obtain a small I1 I2, you have to solve the KVL equation. So for regard to the first step, you have to simplify the KVL equations. So final KVL equations are 2. Those 2 equations we have to solve. Finally we get the answer of I1 and I2. So by using calci, you have to simplify the equations. Now by solving equations first and second equations. By solving first and second equations, we obtain small I1 and small I2. So by simplifying 2 equations, I1 will get the 1 amp and I2 will get the 1 amp. Okay friends. So finally we are obtained the mesh currents only. Now the problem is not yet completed. Just we are completed the mesh currents. Okay na friends. So finally we determine small I1 and I2. Just our question is we determine the branch currents I1, I2, I3. So what is I1? Current flowing to the 5 ohms. That is nothing but indirectly small I1 only. Next, what is I2? I2 current is the current flowing through the 6 ohms. Which current is flowing through the loops? Small I2 is the flowing through the 6 ohms. So I2 is nothing but small I2. So whatever the I3, capital I3 is nothing but current flowing through the 10 ohms. So that I3 is nothing but combination of these two currents, I1 and I2. So I3 is they are given the downward direction. You consider small I1 as a respect. So I1, I3 equal to I1 minus I2. So like that, you have to determine the branch current. So whenever you are solving the problem by using mesh analysis. First you have to identify the mesh currents, then after that whatever the question they are given, according to that question you have to solve the problem. In our question simply they are asking what is I1, what is I2 and what is the I3, is nothing but branch currents they are asking. Okay friends, now finally after obtaining the small I1 I2 we have to obtain capital I1. So here our solution is they are asking I1, so I1 is nothing but small I1 only, so this is equal to 1 ampere. It is clear. Next I2 is nothing but current flowing through the 6 ohms resistor, that is small I2 is nothing but small I2 only, so this is 1 amp. Okay, next final answer is I3, so that I3 is nothing but current flowing through the 10 ohms resistor. In that two currents are flowing, I1 minus I2. I1 is downwards, so I1 minus I2. So finally 1 minus 1 equal to 0 ampere. So finally this is the answer. So finally we simplified the problem. Finally we obtain the solutions. Okay friends, so like that you have to solve the problem by using mesh analysis. Just you go for just you go step by step, finally you will get the answer. Okay friends, so by this we completed the problem. If you are watching video first time, please like, share and subscribe our channel. Okay friends, we will meet in the next class. Thank you.